Okay, so here we are solving some trig equations. All right, second lesson here of Unit 5. I'm getting into some good stuff here. Things to think about when you're solving a trig equation is that all equation solving rules apply. If your answer is not a familiar answer in the unit circle, you're going to need to use the inverse trig functions when you calculate inverse sine, cosine, tangent. Remember to check for multiple solutions. We'll see what that looks like. And the problem may ask for answers on a specific domain or an unlimited domain. Again, we'll see what that looks like. Let's take a look at some examples. So here we go, some basic ones to get started with. Okay, and like I said before, basic equation solving rules apply. So here, if I'm solving for theta, and theta is between 0 and 2 pi, that tells me that I'm on the unit circle. I want to get theta by itself. Okay, so to do that, sorry for these weird looking equations. It's the best I could do. I want active inspire. I'm going to divide by 2. So I have sine of theta equaling root 3 over 2. Now I need to think, okay, on my unit circle, I know that root 3 over 2 is a common side. It's a side that's familiar to me. So I'm going to look at my unit circle. I'm going to find where the y value, because sine is like y, I'm going to find where the y value equals root 3 over 2. So drawing a picture sometimes helps. Sine is y. This number here is a positive number. So I'm looking in quadrants 1 and 2. On my unit circle, quadrants 1 and 2, where is y 3 pi over 2? Well, that would be pi over 3 and 2 pi over 3. So I have two answers for theta. Theta would equal pi over 3, okay, or 2 pi over 3. Next, I'm going to take a look at this one here. I'm talking about cosine now, so I'm thinking about x. Again, equation rules apply, so divide by 2 to get rid of the multiplication. So I get cosine of theta equaling negative a half. So now I'm thinking cosine. I'm thinking x values, and I'm thinking negative. So on my unit circle, cosine is negative in quadrants 2 and 3. And where is cosine negative 1/2? Well, in this particular case, it happens to be 2 pi over 3 again, and 4 pi over 3. And again, I'm looking at my unit circle to determine that. So theta will equal 2 pi over 3 or 4 pi over 3. Next, I have a tangent. All right, remember tangent is y over x. It's a little trickier than the other ones that we've had. So let's take a look and see what it gives us. To get rid of addition, I'm going to subtract. So 4 tangent of theta is going to equal negative 2 root 2. I'm going to divide by 4. Okay, so tangent of theta is going to equal negative root 2 over 2. Now, while that might look familiar on the unit circle, if you think about this, that's an x and or a y value, but tangent is an x and a y value. Okay, so in reality, this is not a familiar answer for us. So I'm going to need to do the inverse tangent of negative root 2 over 2 in my calculator to determine this answer. All right, so you want to make sure your calculator's in degrees, because if you're in radians, it's going to give you some decimal answer that doesn't really make a lot of sense. Okay, degrees usually makes a little more sense to us. So if I type in inverse tangent of negative root 2 over 2, I'm going to end up with negative 35 degrees. Okay, well, that doesn't make a lot of sense. I'm thinking about tangent. I'm thinking about where it's negative. On your unit circle, tangent will be negative in quadrants 2 and 4. So now this is going to make a little more sense, because negative 35 degrees would be quadrant 4. Okay, but what is negative 35 degrees? Well, if 360 is a whole circle, negative 35 will be backwards from that. So if I subtract 35 from 360, okay, I'm going to get 325 degrees. And then here in this quadrant, I'm going to be subtracting that 35 from 180. Again, I'm using the 360 and 180 markers as my references. So tangent of negative root 2 over 2 could also be 100 and, what is that, 45 degrees. Okay, it's a little trickier, but still possible. All right, let's move on to the next slide and see what else we can do. Okay, so again, basic equation solving rules apply. Now my domain is different. My domain is 0 to 360, so that means my answers can be in degrees. So if I add 3 here, I get 10 sine of theta equals 5. I divide by 10, I get sine of theta equals a half. I'm not going to go into as much detail here as far as verbalizing this for you. I'm looking at the unit circle. I'm trying to determine where y is 1/2. That's the first and the second quadrant. So my theta values here are going to be 30 degrees, okay, and 150 degrees. Again, I'm using my unit circle looking for those coordinates. Here, if I subtract 7 from both sides, all right, 3 cosine theta equals -2. I divide by 3. Okay, well now -2/3 is not a familiar angle on the unit circle. Therefore, I will be required to use my inverse cosine of -2/3. That requires a calculator. Make sure again that you're in degree mode. -2/3. I get 131 degrees for theta. Okay, so where is that at? Well, actually, it's 132 if I round correctly. Sorry about that. All right, so where is cosine negative? Cosine's negative in 2 and 3. So the 132 makes sense because that's in quadrant 2. But I need to figure out the difference between that 132 and 180. Okay, so what is the difference there? Okay, that's 48 degrees difference, which means 48 more than 180 will give me my answer in quadrant 3. So if I take 180 and add 48 to it, I would get that other answer of 228. Because there are two answers. So theta is also 228 degrees. Why are there two answers for a lot of these? Well, think about this. Okay, if I would draw a sine curve, okay, and I would draw a horizontal line at 1/2, it intersects 2 times. So that would be an example of why there's two answers for each of these. All right, let's take a look at this last one here. So sine of theta, 9, 5 sine theta equals 9 divided by 5. Okay, so the sine of theta is 9/5. Well, 9/5 ends up being 1.8. So again, that's not a familiar angle on the unit circle, so I'm going to do the inverse sine of 1.8. When I do that, though, I'm going to get an error, okay, undefined. And let's think about this. Why does that happen? Well, that happens because our sine and cosine curves always revolve between 1 and -1. So that's the only eligible range values, 1 to -1. 1.8 is larger than 1, therefore there is no angle that would make that true. And let's move on here. Another example. 2 more here and then we're done, so sorry for the length of this. Okay, so again, a little bit tougher here because we're going to solve for all values of x, so no restricted domain. So now any x value could work. Okay, that satisfies this. So as I subtract 1, these look the same. So 2 cosine x theta, all right, equals -1. So that means cosine of x equals -1/2. All right, I know where cosine is -1/2. That's in the second and the third quadrant because that's where cosine's negative. All right, it's the x value, so that's going to be 2 pi over 3, and that's going to be 4 pi over 3. Okay, but I'm looking for all. I'm looking for all values of x. So yes, x equals 2 pi over 3, and yes, x equals 4 pi over 3. But when I say all values of x, I mean every single time that this circle passes and hits 2 pi over 3. Every time. Every time. Every time. Forever. So I need to add some sort of denomination here. In this case, a full circle is 2 pi n. Okay, n is an integer, and n represents the number of times or the number of revolutions that I've taken. Same with the 4 pi over 3. Okay, so if that confuses you, it's really not that hard. You could just remember that if it's all values of x, I'm going to tag my answer with a 2 pi n. Okay, same thing over here. Sine of x equals √3 over 2. All right, the solving strategy is the same. √3 over 2 is a common angle. Therefore, x sine is positive. So again, I'm going to be at 2 pi over 3, and x is going to be pi over 3. And I'm going to tag that with a 2 pi n because every lap, which is 2 pi around the circle, is going to give me an answer. Now, what does that look like graphically? Because I gave you a graphical example before. Remember, this sine curve continues forever in both directions. Okay, so if I'm graphing that root 3 over 2, which is here, okay, I'm getting an answer at pi over 3, and then 2 pi later, I'm getting another answer. And then 2 pi later from that, I'm getting another answer. And so forth forever. That's what this means. Okay? All right.